Hey everyone, this is Kumar. In this video, I wanted to talk about how to use consumer liking in Bayesian optimization for CPG product development. In product development, we often say consumer is the boss. But what happens when that boss gives subjective, noisy, and hard to predict feedback? Today, we'll break down how to use consumer liking scores, the most important signal in product success, inside a Bayesian optimization engine. So the question is, should you use it as a constraint, as an objective, as both, or neither? We'll cover the math, the strategy, and the best practices from real-world CPG formulation campaigns, all grounded in experience, not theory. Let's start with the fundamentals. In CPG, liking scores typically range from 1 to 9. You might run consumer tests or sensory simulations to predict it. But here's the catch. Liking is noisy, nonlinear, and highly context dependent. It's also often the single most important metric that determines launch viability. So the question becomes, do you optimize for it? Do you enforce a minimum? Do you filter bad options? Or do you let the AI learn what's best? So let's explore the options. The most common and usually the most effective approach is to maximize consumer liking as an objective. Here's why. You use the full richness of the score. You might have 6.2s versus 7.9s. You allow Bayesian optimization to learn what drives higher liking across the space. And you don't restrict exploration too early. What you do is you maximize liking. So you have a function that says, I want to maximize liking. The system will build a surrogate model that's going to predict liking and explore high potential areas. This is especially powerful in multi-round campaigns. Early rounds explore what drives liking. Later rounds converge on high liking regions. You can even visualize the predicted liking surface over the design space, showing the peaks and valleys. Now you might ask, why not just say, I only want formulas with liking greater than or equal to 7? That sounds logical, right? But it's risky. Here's why hard constraints on liking are problematic. Liking is noisy. A good formula might test at 6.8 one day and 7.2 the next day. A good formula might taste 6.8 by one person and 7.8 by someone else. Your model might be wrong early on, so filtering too aggressively removes learning opportunity, so you don't want to restrict it. And optimization works best with gradual gradients, not yes-no decisions. So if you must use a threshold, don't make it binary. Instead, you can use what's called a soft constraint, and we can talk about the details. But let's say you prefer liking to be greater than 7, but you will tolerate a lower value if the trade-off is worth it. Let's say you're trying to optimize for cost, and you want to hit a particular cost number, and so you'll tolerate liking just below 7 if you can also hit your cost objectives. So what you can say is, you can say that, whatever the way you score a new suggestion, what the system will do is it's going to say, well, if you're trying to get to a 7, I'm going to see what the actual value is, and I will adjust the score a little bit, the score that determines whether this particular formula is good or bad, to account for the fact that it's not exactly what I'm looking for on the rating scale. So basically what you do is you penalize the system for missing the threshold. Your threshold was more than 7, but you don't block that candidate formula entirely. So you say, I still want it, just adjust its score, penalize it, so that I still can consider it. And this approach keeps flexibility, allows exploration, and it still nudges Bayesian optimization towards better options. And then you can tune a parameter depending on how strict you want to be, right? How high should the penalty be, and you can tune that over time depending on the recipe you're working on and the other business considerations. Now, if you want to take it to the next level, you could also say that only suggest candidates that are likely to get greater than or equal to 7. That's what's called a probabilistic constraint. You train a model that predicts the liking of a particular value to be greater than 7, and you say, I want that to be greater than, let's say, 90%. So I want to predict the probability of liking greater than 7 to be greater than 90%. And then what you say is, that the optimization system should only sample from areas where the model is confident that the threshold will be hit. That's what it means by saying the prediction for liking being greater than 7 is above 90%. So only sample from areas where the model is confident that that threshold of greater than 7 will be hit. This is extremely useful in late rounds, in market-ready formulations, or high-stakes decisions where the risk, where you want to absolutely mitigate any risk with taking something to market that might not work. But there's a big problem here. You need really good data, and you need a very well-trained classifier to avoid false rejections, and that takes time and effort, and is expensive to get to that point. And so not really a good idea in general. Can be done, but remember, you need a lot of data, a lot of good data, and a well-trained classifier for this capability. So one of the best practices in strategy, if you're in early rounds, you should maximize liking directly. That allows for full exploration of the search space, and you're bound to find the regions that have that hold promise. In the mid rounds, you can start enforcing some penalties for low liking regions, right? So near the borders, you can say, I will apply a penalty to the overall score because you're not hitting the value I'm looking for, but I still want to consider it. In later rounds, you can apply probabilistic constraints or filtered sampling, but always you want to combine your liking objectives with feasibility constraints. So constraints on pH, cost, or anything else. So in other words, optimize liking. Use minimums as filters when you're closer to launch, not at the beginning. Use penalties when trade-offs matter, and let the data drive the decisions. Don't hard code your intuition. It might be extremely, you might be really compelled to put your intuition in the system, but that's where you want to know that the way the system learns, it'll do it itself. You don't have to provide it. You don't have to hard code what you know, because what you know might not be the entire thing, or it might be limited to what you have seen, and might not include things you haven't explored in the past. So just to conclude, consumer liking is where subjectivity meets science. If you misuse it, you overfit to noise or block innovation. If you model it wisely, you'll unlock formulations that are not just feasible but loved. So you just use it as a signal. Let the optimization system learn, protect against extremes, and above all, design the system to reflect real world decisions. Because great products aren't just compliant, they're craved. And Bayesian optimization, the right use of liking, makes all the difference. All right, hope that helps. See you next time.